We are here with Dave to speak about key findings and lessons learned during the Autoplex project. One of the main deliverables has been the demonstration of real-time cooperative perception using V2X technologies and using that real-time trajectory planning capabilities for an ego vehicle on-ramp as it approaches the main carriageway. So Autoplex has been a collaborative R&D project running for the past 3 years, ending this month. Apart from YUNEX Traffic and WMG, other consortium members include Jaguar Land Rover and Public Bodies, Transports for West Midlands and National Highways. At the end of this project, we will be able to claim that at high-speed merges, the right quality and safety for a connected and automated vehicle on-ramp can be enhanced if, in addition to onboard sensing, infrastructure-based perception using V2X communication is also used. So a key element in the Autoplex project has been infrastructure-to-vehicle communication from a roadside unit mounted with radars and wireless connectivity to the ego vehicle on-ramp as it approaches the main carriageway. So perhaps Dave can say a few words about the implementation of the roadside unit.
Okay.
Yeah.
I think everyone can hear me. Excellent. So what you're going to see in the video, which is, and thank you, Kostas.
Yeah.
Thank you. What you're going to see is a roadside system assisting a connected, potentially autonomous vehicle to do a merge onto the motorway. And what we provided essentially is a system integration of sensors and a V2X roadside unit working with 802.11p to transmit messages, as you'll see. Okay.
So the fusion of the onboard sensing at the vehicle with infrastructure-based perception is what we called a collective or cooperative perception using a V2X system. The project has assessed the benefits of cooperative perception using simulation and a proof of concept demonstration. You can see here junction 15 at motorway 40, where the final project demonstration has taken place. Apart from that, the project has been benefited from more than 8 months of data collection using infrastructure cameras located along the merge. And in addition to that, we have collected extended drone footage from several other junctions in order to be able to identify corner cases and interesting road traffic events related to high-speed motorway merging. So I guess I can share with you one video that summarizes Autoplex.
Down. Excellent. Okay. Thank you, Kostas. I hope you enjoyed the video. Any questions about it, please ask us afterwards. I'm Dave Gabbitas from YUNEX Traffic, formerly Siemens Mobility, when we started this project. So the road ahead, following on from the Autoplex project, which is in its terminal phase right now, we finish at the end of September, is basically looking more at sensor technologies. Okay, in this project we used some radars, some tracking radars to detect the vehicles, including the ego vehicle. We're going to have, we're going to look into radar and sensor evaluation studies that have been done as part of innovative work recently. Promote the collaboration that we've had on this project with automotives and research institutes and local authorities. We've been doing this for a few years now. Drive the market engagement regarding the safety potential for this and efficiency. Basically, you're giving the vehicle eyes where it doesn't have eyes, potentially. The question is trust in the future, and that's going to be the big question. Okay, we're looking to engage in future V2X projects, that's vehicle to infrastructure, optimizing sensor arrangements. It may be that we have to standardize the way these things are done, and we need to become part of the entire verification validation framework for these types of systems, for it to be trusted. Okay, also during this project, we were collecting a vast amount of data into the cloud of the motion of all those vehicles that were on the road. And these data sets form a very valuable resource for understanding how traffic moves and helping autonomous vehicles and connected vehicles to navigate well in the future in these kinds of conditions. And I would just say very quickly that as an industry, as Siemens Mobility, most of the traffic lights you see out there are ours, the vast majority in the UK. We're also internationally involved. And we're moving more from just doing roadside systems to integrating systems. And that means with the connected cars. That's what's going on in our industry. We've been focused on road systems. Now we're becoming more involved in system integration. As I said, we participate at ETSI and the Car-to-Car Communication Consortium. So we're involved in these bodies. At the moment, these systems will provide information, but the question is, how will you trust it as automotives in the future? And I think it can only happen by very close interaction, working together, evaluating the systems together, and by defined system operational environments being defined as part of requirements for these types of systems. Okay, and that does come down to the supply chain. So for example, if you have tested sensors, sensor fusion systems, we might be interested. We're becoming system integrators, and our requirements might become part of your requirements in the future regarding range of sensors, validity of the data, and various other things like this. So we look forward to working with you in the future. So, Kostas, I'll just say, yep, that's it from Kostas, and it's goodbye from me as well. Thank you.